level from normal to advisory. At 9:22 in the morning, satellite-based ground deformation data arrives from the Jet Propulsion Laboratory in Pasadena. The INSAR measurements, interferometric synthetic aperture radar, which detects millimeter-level changes in ground elevation from orbit, shows something that makes the overnight duty scientist stop mid-sentence during a briefing call. The Caldera floor has risen, not dramatically, not the kind of uplift you could see standing on the rim looking down at the lake, but 2.3 centimeters of upward ground movement, measured across a roughly 3-mile diameter zone, centered on the South Caldera Basin, occurring in less than 72 hours. For a system that has shown minimal deformation for decades, 2.3 centimeters in 72 hours is not a footnote. It is an alarm. At 11:15 in the morning, a USGS research vessel operating on the lake's surface, one of the monitoring operations that runs continuously at Crater Lake, reports something that nobody on the vessel has seen before: a visible discoloration of the water in the South Basin. A pale, milky blue-white sheen spreading across approximately 400 meters of lake surface. Hydrothermal venting, superheated water, and dissolved minerals pushing up through the lake floor. But it is the hydrophone data, underwater microphones that monitor acoustic activity on the caldera floor, that produces the reading that changes everything. At 2:34 in the afternoon on May 3rd, the hydrophones detect a low-frequency acoustic event lasting approximately 40 seconds. The signature is consistent with one geological process: fracture propagation. The caldera floor is cracking. By 6 in the evening, the USGS issues a formal public statement. Crater Lake volcano alert level elevated to watch. Unusual activity detected. Monitoring continues. What the statement does not say is that 12 hours earlier, one geologist on the morning call used a phrase that is now echoing through every volcanic monitoring institution in the country. She said, and I am quoting directly, "This looks like initiation. The science of what is happening below." Okay. I want to slow down here for a second because this is where a lot of disaster content either oversimplifies or just makes things up. And I am not going to do that to you. What is actually happening beneath Crater Lake right now is both scientifically fascinating and genuinely terrifying, and you deserve to understand it properly. Crater Lake sits above a magma system that has been active in geological terms for the entirety of its existence. The last significant eruptive activity at the site occurred approximately 4,800 years ago, when a small vent on the caldera floor produced a modest lava flow that is still visible beneath the lake in bathymetric surveys. That event was minor, a whisper from a system that, at its peak, screamed loud enough to be heard across a continent. But minor does not mean dormant, and dormant does not mean dead. The magma chamber beneath Crater Lake sits at depths ranging from approximately 5 to 12 kilometers below the caldera floor. It is not a single unified pool of molten rock the way it is often depicted in diagrams. It is a complex network of partially molten zones, crystallized rock interspersed with pockets of melt, all sitting under immense pressure from the weight of material above it and the ongoing heat from below. Above the magma chamber sits the hydrothermal system. This is the layer of rock that has been permeated by superheated water, water that has circulated down through fractures in the caldera floor, been heated by the magmatic system below, and now exists in a state of constant pressurized flux. The hydrothermal system at Crater Lake is extensive. Researchers estimate it contains fluid reservoirs spread across tens of cubic kilometers of fractured rock beneath the lake bed. Here is where the fracture event becomes critical. When the hydrophones detected crack propagation on May 3rd, they were not detecting the magma chamber itself breaking open. They were detecting the hydrothermal cap, the overlying rock layer that contains and pressurizes the hydrothermal system, beginning to fail. Think of it as the lid on a pressure cooker developing a crack. The contents have not escaped yet, but the structural integrity that was keeping everything contained is now compromised. Dr. Rachel Simmons, research geophysicist with the USGS Cascades Volcano Observatory, explained the significance during a briefing that was not intended for public release, but was obtained by natural disasters through a source inside the agency. Her words were direct. When you see fracture initiation at this depth, coinciding with ground uplift and hydrothermal surface expression, you are looking at a system that is actively pressurizing. The question is not whether there is a pathway developing. There is. The question is how fast that pathway grows and whether the overlying structure can accommodate the pressure, or whether it catastrophically fails. Catastrophically fails. Those two words are doing